Hello, Ubiquiti enthusiasts. This last week, while teaching a class, we had a discussion about concurrent users, and I want to continue that discussion with you. And let's take a look at concurrent client capacity. So Ubiquiti says that you could have on an AC Pro data on their data sheet. It says you could have 125 concurrent clients. And so we discussed how they came up with this, and not really sure how they did it, but probably using really wide channels and expecting really high data rates from all their users, which isn't real practical. So we need to dig in as engineers, we need to dig in a little bit further and see if we can come up with the correct number. So they go on to say that with the AC Pro, you could have the recommended number of users would be 70 concurrent users. And with an HDAP, that the recommended would be 350. And then they give a theoretical max. And they also have a link to a pretty good document on high density there. You could use that link and get a little bit more in depth of what they say. But if you're just going by what's advertised, you're probably going to run into troubles. So what we try to do is determine how much bandwidth our users are going to need. So instead of coming at it from the access point of view, we want to come at it with our supported users. And so I throw up this modulation encoding scheme chart to say that, typically our users are going to be using two spatial streams, right? So all the iPhones up through iPhone 14, Androids, almost all laptops and tablets are using two spatial streams to talk. So whether our access point has 4 spatial streams, 3 spatial streams, whatever, the clients can only utilize 2 of them at a time. Okay, so it's nice that they can use 2, but that's going to be the extent of it. So we should look at what size channel we're going to use. 20 megahertz, 40 megahertz, 80 or 160. And in a high density environment, we're going to use a 20 megahertz channel so we can have more non-overlapping channels in our channel reuse plan, but we may use 40. So I pulled out the 40 megahertz two spatial streams portion of the MCS, and you can see that it lists from 30, and that's throughput 30 megabits per second down to 400, or I should say up to 400. So if we had all of our users were capable of neg 54 or better, then we'd have 400 megabits per second throughput to share. Now, that would mean that if we just had one user could use 400 megabits, all 400 megabits. That's all they could use the whole thing. But if we have 100 users at 400 megabits, then each one would get 4 megabits per second, right? Well, thinking that all of our users are going to be at neg 54 is a bit of a stretch. Like they all have to be right underneath it, right? And so it would be difficult to have 100 people all right underneath one access point, even if you're in a stadium and it's really tight. I think it would be difficult for everyone to get neg 54. So a more realistic number is to take the middle of the road, right? And so say neg 67, we could get 180 megabits per second. So with that, if I have 100 users, I'm going to get 1.8 megabits per second per user, right? So, and then we have to plan for overhead. So Devin Aiken, one of the original CWNEs, has this article, and he talks about access point data rates are only half of the equation. So we need good data rates, yeah, but a couple of things to look at on this slide. This says what one access point can support with clients at neg 67 and 5 gigahertz on a 20 megahertz channel. Okay, so we could probably just double it for a 40 megahertz channel if we end up using that. But he has 3 spatial streams and 2 spatial streams with tablets. Let's look at 2 spatial streams. notice that one of the important things he's saying is that 75 to 80% of airtime utilization is a maximum. So on our access points, we can see the utilization of a channel, and yeah, if it's getting up to 75%, you'll see that it's very, very heavily used. And the software, the controller software or the network application software is probably going to recommend a different channel. So let's take two spatial streams, a 20 megahertz channel. This says that we could put 21 devices on it and have 75% total airtime utilization, right? So quite a far reach from 100. This would give each of the users 3 megabits per second, which is good. I think they could have a pretty good experience with that. You may want more for certain applications, but most things that people are doing on their phones or on their laptops will be 3 megabits per second or less. You can look at, if you've got deep packet inspection on, you can look and see which applications are you can look at a list of the applications and see which ones are using, how much data is being used for each application. So might be something to look at to help you get an idea, right? So 21 on a 20 megahertz channel, maybe 42 to 45 on a 40 megahertz channel. But that's how you should start to view things, is by how many can be supported on a channel. So getting up to 70, you could possibly do 70 if you considered that you have a 2.4 megahertz channel and a 5 megahertz channel, but really any more than 50 is going to be stretching it. Okay. Thank you.